A HSC question like this has a couple of different parts to it. Now, usually in HSC, this would be an explain type question. They want cause, they want effect. So you need to make sure that's really clear. Now, all of our questions here relate to this image that you can see on the left-hand side. So, question 4 says that we need to actually analyze what's happening to this system. Okay, so starting off with, if I have a look at site A, which is our most important one for the McDonald's hatcheries, you can see here the dissolved oxygen is about 4, biochemical oxygen amount about 35, pH 7.7, which is good, nitrogen, phosphorus are quite low. Perfect. Now, if we start at the very top of this system, you can see here, if we start looking at E and D, dissolved oxygen, quite high, as you'd expect. There's going to be a lot of movement, a lot of flow through water, and you're going to have that dissolved oxygen in the system. Biochemical oxygen demand, as we said, quite low, so it's a healthy system. pH, well, that's pretty okay. Probably should be a little bit lower for your 8, but that's okay. Nitrogen and phosphorus quite low. Once you get to the bovine farm, this is where you're starting to see your problem. So site C, your dissolved oxygen, level of 1. So you can start to see that whatever is in the system is actually starting to remove some of the dissolved oxygen in there. Biochemical oxygen demand. So this is your BOD 5. This means that whatever is in your water is actually requiring a substantial amount of oxygen. There's a large oxygen demand in your system. pH of 4.2, that is quite acidic for a major waterway. Total nitrogen and phosphorus is incredibly high for that system. So high that you almost assume that this is going to be undergoing eutrophication. With this in mind, the most likely cause of all of these different sites that is actually causing this death of fish at the hatchery is probably this bovine cattle farm. And as we said, it's because of these relationships within the environment. Now, the reason site E is so important is because, for all intents and purposes, it is the control. It is the natural flow of the water. Now, if you have a look in site E, as we said, site E has excellent quality water. It's clear, highly oxygenated, and its quantities in terms of nitrogen and phosphorus are incredibly low. For question 6, it says that you actually need to describe the trends throughout the system. Now, what I would do, if this was an explained question in the HSC, I would literally go through, pick a few main points along that system and describe what's happening. So, as we said, for example, if we're looking at the dissolved oxygen, we would start off by saying the dissolved oxygen in site E is rather high, at about 9. As it moves through the system towards site C, when it hits site C, all of a sudden the oxygen is getting removed from the water. The biochemical oxygen demand is increasing, proving that there is some sort of biological contaminants that are going into this system that's utilizing all that oxygen and causing the dissolved oxygen to decrease. As you move throughout the rest of the system, by the time you actually start to get site B and A, all of a sudden these biochemical oxygen demands aren't necessarily as prevalent as they were previously. So you can see what that major sort of contaminant is. With your pH, as we said, moving through the system, at site E, starts off rather healthy at 8 and 6.9 as you move through the system. Once you get to site C, at site C, you see that the pH drops to 4.2. Now that's really likely in relation to how biological contaminants, so for example, manure, urea, all these things are going to acidify your water. As it starts to go through the rest of the system, you'll find that these sort of compounds are actually going to start to get diluted in your system. So that's going to result in this drop in pH up here. Going through with your total nitrogen and total phosphorus, starting off E, D, and C. Once again, they remain quite low until you hit site C. This means that probably the nitrogenous waste that's going into the system from the actual manure itself is causing that flourish of nutrients into the system. As you keep moving through, those once again start to decrease again. Now, the important thing here is when we're talking about nitrogen and phosphorus, we're keeping this idea of eutrophication in mind. And it is quite clear. Now, eutrophication usually occurs when your nitrogen to phosphorus ratio is less than a ratio of 10 to 1. Now, in these examples, what you'll see here is all of these are kind of around a 10 to, well, less than a 10 to 1 ratio. This is an 8 to 1 ratio. This is a 5.5 to 1 ratio. This is a 1 to 1, almost a 1 to 1 ratio. That is showing us that this is an incredibly likely possibility for eutrophication. This is 3.8 to 1. This is 20 to 1. Now, as we said, if your number drops below a ratio of 10 to 1, you're likely, or you're increasing your chances of eutrophication. So at the beginning of our system at site E, there was close to no chance of actually undergoing eutrophication. As you start to jump up, all of a sudden we start to see this increased likelihood. Now, to improve this, as we said, Clara's bovine farm is probably the most likely source of contaminants. In order to actually stop this occurring, it would be desperately encouraged that she not discharge her manure straight into the waterway. Other suggestions would be now you couldn't just say don't discharge into the waterway. You'd have to give possible outcomes. So for this, you could actually say that instead you're going to encourage her to actually treat the manure and use it as fertilizer instead, rather than just discharging into the waterways. You could also talk about increasing aerobic digestion before any sort of release into the waterways. That would that would actually allow for the breakdown rather than just the release into the waterway. Now, to actually look at this whole system, it's actually incredibly important that all users of your waterway actually keep in mind the flow and discharge of water. Local authorities need to report from and report to environmental chemists to determine whether or not landholders are adhering to guidelines in the disposal of wastewater. As we said, it's important for everyone in your biological system to make sure there's monitoring and management occurring.